Danish startup Solar Foods is one of a handful of players using gas fermentation to make protein from thin air. So what are the pros and cons of this approach?
So when we are using gas, we are of course using renewables to make the gases from the water. So we split the water in electrolyzer, so we make a hydrogen and oxygen. So of course you don't have too much the emissions coming from that and that. We also are having a direct air capture to collect actually CO2 in our office, and also with other sources. It's also renewable point of view, very, very green. And if you compare now this for the sugar fed, so it's 5 times more the kilos of CO2 if you think about this. And that's coming because you need to grow this sugar field and you need to transport that actually to a place. We do on the spot in the factory everything, the gases. If you think about economics point of view, it's very simple process what we have, because if we have a tank, we put all the gases there. We don't need any kind of upstream actually to get anything there. So if you have a sugar, you always need to perhaps place your factory either close by to get your feedstock. It's not the same situation with us. We can place anywhere.
What about the issue of contamination? Is there less risk of contamination if you're using gas fermentation because you haven't got kind of competition with the microbes to eat sugar?
Great question. So just an example. So we had a continuous production of the 8 months without any contamination. It's a really continuous. It's not batch. It's continuous production.
But with your model though, with electrolysis, does that kind of constrain you to certain markets where energy costs are lower?
Not necessarily. So we have done, of course, our sensitivity analysis. So what I commented, the 40 euro per megawatt hour, we have also done that. What about if the electricity price is 2 or 3 times higher? Still the business case is very, very good. So it's very efficient process as such. That's the key principle actually why it makes sense. And COGS of the operations goes very low.
But what about carbon dioxide? You talked about direct air capture. I mean, that is pretty expensive at the moment. Is that viable for these first generation gas fermentation plants?
Today in our first factory we are using as a test purposes. So we food out of thin air, so how it works indeed. But the scale what we are planning, I think there is still work to do. So that's why we are considering to take a biogenic CO2. There's a lot of industries in Finland especially where you can get this CO2 easily, which is actually like a renewable type of the CO2.
Okay. So tell me about Factory O2.
We have said publicly that we are selecting the site this year.
Yes.
So we have 3 options in Finland. We have also options outside of Finland.
Yes.
One of those, what I can mention, is Denmark. Very good location. We also have been looking for the Middle East and US.
So if you're planning to build Factory O2 in phases, when do you think the first phase might be operational, and can you be kind of profitable from phase 1?
All our phases will be profitable.
Yes.
Our first phase is the aim to be ready and release 28.
Okay.
So in 3 years from now.
Do you have kind of, in terms of demand from the market, do you have letters of intent or offtake agreements yet?
But we have MOUs and LOIs, more than 50% of this factory already.
So how are you actually pitching the ingredients?
Our target market is a health and performance market. It's a premium market where the whey protein isolate is typically the standard reference. We know that there is not enough supply for that one because whey is a byproduct from the cheese production, and there's not more dairy or cheese plants coming. It's rather actually the flat growth over there. Same time, health and performance is growing more than 10%. Some segments actually even 14% year on year. So there is a supply gap all the time. There is always 3-5 things what actually people are looking for. First is a nutritional aspect. How good is the protein? So how much you have protein? So we have more than 80%. We have actually all 9 essential amino acids. We have 20% this kind of branch amino acids, which are typically what people are looking at. And we have 9% of the leucine as well, which is actually very, very essential for that. That's typically what this health and performance segment personas they are looking for. They're also looking for the taste. Our taste actually in a Solein is very neutral. It's very easy actually put a different kind of flavors, and you don't need to mask it. The third one actually is functionality.
Yeah.
We have a protein, we have also fibers, 10%, 40% is a beta glucans of those, and we have 6% of healthy fats, which is like a olive oil or avocado type of the fats. So it's a very, very good composition of everything as well.
What about the colour though? Because it's bright yellow. Is that going to limit its applications, or is that part of the appeal?
It could perhaps limit some applications. It's a natural color. It's from carotenoids.
Yes.
It's like a carrots have the similar color, but it's not. Some of the applications actually it's pretty white or whitish. Get it absolutely clear white. It's a challenge, of course, and that might actually affect the way you can apply it. But it's very, very little. If you compare actually. We made actually the mayonnaise case and a press release just yesterday. I don't know if you have seen it. So Solein, we compared actually the white mayonnaise, one of these huge global leading companies who are doing it. So we made exactly same color white mayonnaise, but we need to use only 1/3 of the Solein compared to egg yolk.
Yes.
What you actually needed. So it's a huge business case
Yes.
for that. And the color was same.
Yes.
Texture was same.
Yes.
Taste was same.